proton explosion and any obvious inclination in between. And so here's some figure for RSO. Here's a couple more HSD RSO, T Pixidus. You can see here it is John, I equals 90. Here's looking polon, I equals 0. I took this from Shazreen, don't tell her. Okay. So here are my conclusions. Motherhood, classical recurrent novae are binaries. Apple pie, they have survived common envelope evolution, no? Okay. There are two composition classes. The shaping of the ejecta occurs almost immediately. Our spectra taken right away show all kinds of profiles suggesting that they're already doing whatever they want to do. The ejecta are asymmetric. Their observed shape depends on how we're viewing them. And if you want to talk about how planetary nebulae evolve and you want to do it fast, the stuff starts off hot. It cools as it expands. But then the hot underlying white dwarf gradually, or not so gradually, depending on how much material has been injected, heats the white dwarf on timescales of weeks, not centuries. And I'll end with the last. Classical and recurrent novae are neither spherical nor uniformly filled. Novae theorists. Thank you. I mentioned that on Tuesday or Monday. That's the Natalie Battaglia's summary from her talk about Kepler novae. You can look at that while I answer any questions.
Yeah. Thank you. Any comments from the theorist? One to back, the famous one. What's his name? Adam?
It's impressive just how much these look like very fast versions of at least part of what we see with the protoplanetary nebula. Right? Part of our dilemma is protoplanetary nebula seem to be where all the action is happening. The one thing I don't see in this though are the jets. You get collimated outflows, but what we also see in protoplanetaries are also inner beams, tightly collimated beams. So I guess is there any evidence for actually those tightly collimated beams as well?
That would be pretty hard to do because we're looking at all novae. I will say that the theoretical studies we're doing of accretion of material, we are getting stuff off. That stuff could very well be in jets. I honestly think that these objects that are central stars, what are called planetary nebulae, have just been ejecting a lot of material with time as part of the accretion and mass transfer process. No, but we don't see what you would call these jets. I mean, certainly not the kinds of things you see in young stellar objects, the Pervigaro objects.
No?
I have two comments. One is the survival of the common envelope. Of course, these CVs survive the common envelope. This is why when people have been suggesting, including me, that there, in some cases, actually many cases, the merger at the end of the common envelope is not fully accepted in the community. But I think that this is very important to notice. But there's, I think, a huge problem in the common envelope, the way we treat it. Second is a question of Adam about jets. Look on bubbles, bipolar structure in a cluster of galaxies. If it was not for the radio, which is also not a jet, just filling the bubble, you see no jets, but you see clear bubbles. So in cases where the jets immediately interact with material close to the center, we will not see them unless the object is very close, we are very lucky. So in many cases, jets, so novae probably are cases where the jets interact with material very close to the system.
Sure. Okay. I think you already said that in your talk.
Adam was not here.
Any observer wants to flashlight your poster?
Do you have a comment for the high mean abundances found in some knots in Able 30, which is one of the born again planetaries, and also found now in Able 58, which is also an arc-4 so it has an arc-4 past? So the really, really high that vary between 10 and 30% by mass.
Oh, we do that easily.
Yeah, so
I mean, the point.
do you need an oxygen nova for that?
Yes, you need an oxygen neon nova. You're mixing accreted material with core material that is oxygen neon enriched, and the neon is brought up into the accreted material. The explosion blows it out. We do get 20 to 30%. I would have to look up.
It's actually almost identical to nova abundances, but the ejection speeds are low. They're about 100, not anywhere near what any nova has, and that's a puzzle.
Well, we should work on more energetic objects.
Final question?
I was just going to say, on the correspondence with the nova and the jet situation, I mean, it could be that there are separate processes, but there's nothing preventing an accretion disk from producing a jet, but then also supplying material to produce a nova.
Oh, it's the calculations of mass transfer in many cases assume conservative mass transfer, so it all ends up on a binary. But that can't possibly be true, because you couldn't. Conservation of angular momentum tells you there's got to be stuff coming out of the system in order to get stuff onto the white core. But it's, it shouldn't be enriched unless the secondary has absorbed some of the material from a previous outburst. And that, in fact, there are new observations. Tom Harrison and his colleagues of the secondary stars, and many of them do not have normal abundances.
Okay, thank you again for a very interesting talk. The next speaker will talk about stellar evolution in the real time, meaning about 15 minutes.
Time